To our monthly meeting. ASSA's mission is to observe, understand, share and enjoy the wonders of the universe. I've got more to say in terms of joining for those who are visitors here tonight. Who is not a member of ASSA? Could you put your hands up, please? That's a good turnout. Thank you for coming along tonight. We hope you find tonight's meeting rewarding. I'll have a few more things to say about joining a little later in the session. The Astronomical Society of South Australia acknowledges and pays our respects to the Kaurna people, the traditional custodians whose ancestral lands we gather on. We acknowledge the deep feelings of attachment and relationship of the Kaurna people to country, and we respect and value their past, present and ongoing connection to the land, sky and cultural beliefs. Tonight's program, fairly short agenda, main presentation, announcements and upcoming events, and close and supper through the foyer which you came in on. Tonight's speaker, Michael Mattiazzo. He's a local lad, born in Adelaide. Michael became hooked on comets after observing the first and most famous periodic comet of all, 1P Halley, during its 1986 appearance. Some of us might remember that. The younger ones, perhaps not. Who remembers? Some hands? Very good. We have some comet enthusiasts in the audience tonight. Good to see. Since then, he has visually observed over 250 comets and photographed countless more. Michael has been a member of ASSA since 1990 and is a past president. Michael has had the privilege to know one of the greatest visual comet hunters of all time, Bill Bradfield, also a South Australian, who gave him mentorship. Since then, Michael has had the discovery credit for 10 comets using data from the NASA SOHO spacecraft's SWAN ultraviolet camera. Ladies and gentlemen, can you please make welcome Michael Mattiazzo? Do you want a microphone?
Thank you very much, Gerhard. Any chance to turn these lights off, perhaps? Or... Yeah, terrific. Fantastic. And advancing that way. No worries, very good. So fingers crossed, yes, we got the right lecture. Excellent. So tonight I'll be discussing the historical aspects of the Kreutz family of Sungrazing comets. And then a bit later on, I'll be chatting about its most recent member, which was C2026 A1 MAPS, which was discovered earlier this year. This is an image, one of the last images of the comet taken prior to perihelion from the ground-based observers. This one by Terry Lovejoy, who has had the privilege of discovering one of these members. But more on that a bit later on. So what is the Kreutz family? Now, Heinrich Kreutz, born in 1854 to 1907. So during the 19th century, several exceptionally bright comets appeared, passing within a few solar radii, hence the term sungrazing. Now, most notably, in the years 1843, 1880, 1882 and 1887. Now, Heinrich Kreutz, by the name, is obviously a German astronomer. He did a lot of research on these comets and noted that they had very similar orbital parameters. And in 1888, he came out with a paper proposing that these were related and suggested that they were fragments of a single progenitor that underwent a series of fragmentations, either centuries or millennia earlier. But since Kreutz's time, there were other players. Now, Brian Marsden, he was the director of the Central Bureau of Astronomical Telegrams and Minor Planet Centre, who knew Bill Bradfield very well. He basically announced all of Bill's discoveries pretty much during that period. So Brian Marsden was basically director since the 1969 to near his death in 2010. So he took up the case of the Kreutz family during the 80s and 90s. But since that time, further members appeared, notably the great comet of 1965, Ikea-Seiki, and a few other minor ones, 1945 Dutoy, which didn't survive, but the other two did, 1962 Pariah and 1970 White Ortiz Bolelli. Interestingly, Graham White was an Australian amateur astronomer who discovered that comet using a pair of binoculars. So Brian Marsden, he established that there were two distinct populations, and he coined them Type 1 and Type 2, based on the orbital parameters. And there was basically a 20-degree difference in the longitude of ascending node, which I'll discuss a bit later. And then following Brian's death in 2010, the current researcher is Zdenek Sekanina, and he's recently published an extensive series of papers discussing the existence of a super Kreutz system of sun-grazing comets. And his papers are freely available. If you look up arxiv.org and search for his full name, and you'll see them all. A lot of recent papers, fantastic and interesting. And a lot of this stuff that I'm going to be talking about tonight will be based on his research. So he introduced a contact binary model as the progenitor, hypothesized to have split in the year -371, with an estimated orbital period of 750 years. So -371, 750 years. So his cascading fragmentation model gained further support when in January 2019, NASA's New Horizon mission conducted a flyby of the Kuiper Belt object Arrokoth. And this revealed a 36-kilometre long contact binary composed of two planetesimals measuring 21 kilometres and 15 kilometres in diameter. So this is our only ever picture of a Kuiper Belt object. Now, Kuiper Belt objects are located beyond the orbit of Pluto. Now, the progenitor was actually, the Kreutz progenitor was somehow flung into the inner solar system, and it was likely to have been at least twice this size. So let's look at the orbit for a Kreutz. Now, this is a depiction of comet maps in late March 2026. Now, viewing strongly favours the southern hemisphere. Bit hard. Do you have a laser pointer at all? Perhaps. No laser pointers. Oh, the mouse. Okay. Oh, yeah. Mouse. Okay. Yep. Excellent. So yeah. So this is the plane of the ecliptic. This is the blue line's Earth, and then below that is our Kreutz comet. You can see that it's got a very, very high southerly orbital tilt. Now, the perihelion distance is extremely small, 0.005 astronomical units. Now, 1 astronomical unit is the distance between Earth and Sun. Now, the aphelion distance, which is its furthest point from the Sun, is around the 150 astronomical units. So 150 times the Earth's distance. So Pluto's about 40. Neptune's about 40 AU. So you can get an idea of where it's come from. Now, favourable arrival times occur between October to March, with December being the best. So during December, Earth is in this position. So we will see the comet a lot closer to the Earth. And a September to December arrival will result in a morning sky appearance, whereas a January to April arrival will result in an evening sky appearance. Now, May to August, the arrival may come and go unseen as they approach and recede directly from behind the sun. So the Earth is going to be way on the far right, so well away from the viewpoint. Now, as I say, it's very highly southern favoured, but these comets can be seen from the northern hemisphere. Best observed during equinox, so around September to October, and February to March is when the northern hemisphere people do get to see them. But if they turn up in December, you can forget it. The northern hemisphere, no go. The comets appear directly below the south celestial pole. So knowing where to look, you can search historical records over the thousands of years to try and pinpoint prior Kreutz appearances. Now, as you probably can imagine, the southern hemisphere would have seen pretty much all of them, but they don't go by unrecorded. So not until the European settlement in the 1800s do we start getting southern hemisphere reports. So most of this stuff is northern hemisphere biased. So let's look at Sekenina's proposed hierarchy. And it all began in -371 with the proposed parent, the granddaddy of the Kreutz Sungrazing family. And it was witnessed by the Greek philosopher Aristotle, who actually at the time thought that comets were atmospheric phenomena, not solar system bodies. So he made observations of this comet during daylight, and then later an ancient Greek historian, Diodorus Siculus, quoted, "There was seen in the heavens during the course of many nights a great blazing torch, which was named from its shape a flaming beam. This torch had such brilliancy and its light such strength that it cast shadows on the earth similar to those cast by the moon." So if you can imagine seeing something like that in the sky, it would have been a one in a millennia event, an unbelievable sight. And it was also reported, Euphorus of Syme reported that the comet had split into two planets, which he thought they were two planets. Now Sekenina has recently published a paper on this comet using observations so long ago. Imagine 2,300 years ago. He actually calculated a date of perihelion date of January 20 -371. Now this object would have been spectacularly visible in our evening sky way back then. So let's wind that clock forward 750 to 80 years to the Roman times. So there was a comet witnessed in 363 AD, which was the first return of Aristotle's comet. And it was recorded by a Roman historian, Ammianus Marcellinus. In broad daylight, comets were seen. Note the plural form, comets, rather than a comet. Aristotle's comet was expected to have returned to perihelion in 363 as a swarm of fragments, as there's no time for their dispersal along the orbit. And the appearance in broad daylight implies extraordinarily brilliant objects. But there was a bit of lack of detail to his commenting, though. He should have mentioned exactly how many comets. That would have been nice. But it would have been at least two. And the time of year, there's very little other information in historical records apart from a Chinese sighting in August, which is a very unfavourable time. So it's most likely that it occurred then. But you can imagine the breakup in -371. That's now witnessed. So you're witnessing two comets at the same time during daylight. What an astonishing sight that would have been. So now think ahead another 750 years. We have appearances of two comets, this time separated by 32 years. So these two major fragments over that 700 years have slowly separated in time, arriving 32 years apart. So the great comet of 1106 was well observed and recorded. This Belgian historian, Sigebertus Gembelensis, writes that on February 2, a star appeared during the daytime, about a cubit from the sun, 1 degree. And later described by the Japanese as a gigantic comet appearing in the southwest with a tail stretching 100 degrees across the entire sky. Now, 100 degrees, I'm not sure if you know, but 90 degrees is horizon to overhead. And from Southern Hemisphere perspective, it would have basically been vertically above the horizon. Now Sekanina proposed that this was the return of the first lobe, which was population 1. And then 32 years later, the comet appeared in 1138. Now, there's not much information about this, but it arrived during that very unfavourable time of August 1138. So it was recorded by the Chinese as a broom star on September the 3rd, seen in the east and going out of sight by September the 29th. And Sekanina proposed that this was the return of the second lobe, population 2. So winding the clock forward to 1843, the Great March Comet. Now, the 1843 comet is the proposed return of the Great Comet 1106. It's just been slightly cut out by that sign, I'm afraid. But it's above and to the right of the sun. Now, this was one of the most splendid comets ever seen, spotted in broad daylight near the limb of the sun on the February the 27th. This is a painting by Charles Piazzi Smythe with a foreground seen in the Table Mountain in Cape Town, South Africa. I've actually seen this painting. It was located at the Greenwich Observatory in London all of 15 years ago. So maybe it's still there. But yeah, sorry about that sign there. You can't really see the comet. However, once it passed the sun, it became a spectacular object in the evening sky, sporting an extremely long tail of high intensity. over 50 degrees in length, equivalent to 2 astronomical units or 2 Earth-Sun distances. And this painting by D.A. Hardy is a nighttime view of the Great Comet around March the 23rd. And if you look carefully, you can see the constellation of Orion above the comet's tail. Now, our view of that would have been a vertical tail above the horizon. So that's the 1843 comet. So now slightly longer than 32 years now. So it's now out to 39. There's a 39-year gap between the population 1 and the population 2. So there was a great comet, C1882 R1, first reported by W. Finlay at the Royal Observatory, Cape Town, South Africa, on September the 8th. Now, surprisingly, it was actually bright naked eye at the time. It should have been discovered a lot earlier. Now, it brightened very rapidly and was visible in broad daylight by the 17th of September, 1882, reaching an estimated magnitude of -13, which is brighter than the full moon. And then after its perihelion passage, it moved into the morning sky and was a very prominent object, sporting a brilliant 20-degree tail. Now, September is a slightly unfavourable time of year as well. Had it occurred 2 months later, 2 to 3 months later, it would have been an unbelievable sight. That tail would have been easily twice that distance. And this is a painting by Jose Maria Velasco of the Great Comet, 1882, at the National Gallery in London. Now, interestingly, on the 30th of September that year, several observers noticed that the nucleus was elongated and breaking into pieces. And a couple of weeks later, no less than 5 fragments were spotted. Now, this is very good support for the cascading fragmentation model of the Kreutz system. So these 4 fragments here will return in a period of 600 to 800 years in the future as separate individual comets. And not necessarily at the same time, but they'll come back as a cluster. But wait, there was more. Great Comet 1965, so nearly 80 years after the 1882 comet. Now, this was comet He, one of the most brilliant of the 20th century. Now, the orbit was remarkably like the comet of 1882. Therefore, it's the member of population 2. Now, this was a smaller fragment, and it was discovered on September the 18th, 65, independently by amateur Japanese astronomers Ikiya and Seiki. And it became visible during daylight on October 20, with some estimates putting it at about magnitude -10. After rounding the sun, it was a magnificent object in the morning sky, sporting a 30-degree tail. But most notably, it too fragmented into multiple nuclei. So it produced three nuclei, which again will come back in 600 to 800 years as a group. Now, something very interesting occurred in 1995 when the Solar and Heliospheric Observatory was launched, or SOHO for short. Its primary mission was to study the sun and the solar corona, but it ended up becoming one of the most prolific comet hunting machines ever created, with a total of over 5,200 comets discovered to date. And most excitedly, the majority are Kreutz Sungrazers. Now, they're all intrinsically faint and burn up as they approach the sun. So they were given the term SOHO dwarf. And these are the end product of this entire fragmentation process. What was interesting, though, was the notable increase in the numbers during the 2000s, which indicated that there might be a big one returning soon. So this is a compilation of notable Kreutz members visible in the SOHO LASCO C2 coronagraph. Now, a couple of things to note here. North is that way, south is that way. So they're all below the ecliptic. Ignore that, that's just a planet passing through. As I said, all of these were destroyed apart from this one here, which I will discuss shortly. That was Comet Lovejoy, the only survivor out of that lot. So this is a very interesting histogram showing the populations of the SOHO Kreutz Sungrazers. Now it's a revised set of 220 selected objects visible in the C2 coronagraph. So now I mentioned Brian Marsden. He described population 1 versus 2 due to the difference in longitude of ascending node. But what have we here? So there's two things to note here. Note one, that there's a lot more fragments in the population 1, a lot less in population 2. And we have something else here. We have other subgroups, population 2A, population 3, 3A4. We have 3-1. And the major comets are marked here. So 1843 is the existing POP1 main object, and 1882 is the existing main 2 object. But note that both of those fragmented, whereas this one, the POP1, has not. So it's obviously the largest of the mass objects. So that's the one to look for in 750 years. So I'll swing back here. So I did mention about POP3, which is the Great Christmas Comet of 2011 W3 Lovejoy. How many people here got the chance to see that? A handful? Yep, there's a few, yep. So this was discovered by Queensland amateur Terry Lovejoy. Good friend. This comet has had an orbital period of about 650 years, so slightly shorter than the main bodies. Now that dived into the sun on the 16th of December 2011. Not exactly, but within one solar radar of the sun, peaking at magnitude -4. So you can see that's nowhere near as bright as a Kiyosaki, which I said was -10. So -4 is about Venus's brightness. -12 is the moon's brightness, full moon. So the nucleus survived, which to everybody's shock, because everybody just expected it to disintegrate like all the others. But it only survived for 4 days before it broke apart. Later to become a spectacular headless comet, as you can see. This is the image of Lovejoy on the 21st of December 2011. credit to Velo Tabur, who lives in Canberra. This and I was up that morning as well, and it was a very obvious 11-degree tail that morning, much brighter than the Milky Way, and stood out even in bright twilight. And then by the 24th of December, that tail had grown twice that size. It got to 20 degrees. And then by the 26th, it was 30 degrees. And photographically, out to 40 degrees. So the benefit of a December arrival. So this was the most favourable appearance, December. So if it had arrived at any time, months earlier or later, it would not have been as spectacular and probably wouldn't have reached great status. So yeah, so this was a bit of an oddball. It didn't fit the Pop 1 or population 2. So it got its own designation, population 3. So that's the short history of the Kreutz family, and so now I'll just discuss the latest member that was discovered earlier this year, which raised a lot of excitement. It was discovered on the 13th of January. It was an amateur discovery. MAPS, so it's an acronym for their surnames Maori, Attard, Parrot, and Signoret. And the perihelion was due on the 4th of April this year, and the distance was 0.00547 astronomical units. Quite precise, isn't it? Or equivalent to approximately 820,000 K from the Sun. So when it was discovered, it was the earliest discovery of the Kreutz type. So it was found at 2 astronomical units. So no Kreutz has been discovered this far out. So it was highly anticipated and monitored very intensely on its way in. When it was discovered, its intrinsic brightness suggested that it might not survive, but nobody had thought that Lovejoy would either. Because Kreutz comets, if you can imagine, they don't obey regular cometary behaviour because they've been totally baked to intensity at any prior pass. You've got basically the solar corona's 2 million degrees Celsius. You try surviving that. So Sekanina was very excited as well, and he came out with a paper on it, basically stating that the highly unusual trait of the comet ascertained was its extraordinarily long period, at least twice as much. So determined the barocentric orbital period is 1,672 years. That doesn't quite fit with the 750 year that the main bodies are running around in. So if you trace that back in time, it may have been consistent with a fragment released in 363 AD, Marcellinus's comets. But Sekanina then concluded that MAPS could hardly be one of the very massive fragments. If you can kick something into an orbit twice as long, it's probably a lot smaller than what you think. And where did it fit in the family? It was a member of Pop 1, but a side branch. So it's broken off the main 1843 comet, but way back in 363. So it's amazing that you can tie all this in. And fortunately, due to its early discovery, we were able to get the James Webb Space Telescope onto it. Because don't forget, James Webb can't point anywhere near in the solar direction. We need something that's way out on the other opposite side. So luckily, it was found early enough. So this is a James Webb image of it. And from that, they determined that the nucleus size was estimated at around 0.4 of a kilometre. That's only 400 metres in diameter, which was towards the lower end of the nucleus size estimated by Comet Lovejoy, which was around the 500 to 700 metres. So it's touch and go whether it would have survived. And now this is a light curve comparison of maps to previous Kreutz comets. So I'll just describe this to you. The x-axis here is the heliocentric distance log scale. So 1 AU is where the Earth is at, going down to 0.1 AU. And this is all pre-perihelion, so it's on their way into the sun. And our y-axis, this is the brightness scale. -5 is Venus. 0 magnitude is your brightest stars. That's barely naked eye, 5th mag, and telescopic down that way. So this purple curve is the 1882 comet, a very big Kreutz. That's where you really want it to be, up here. And you can see the Ikea-Seiki 1965. That's about 3 magnitudes, at least 3 mag fainter than the 1882 comet. Yet it still became a great comet. And that was found about 1 AU from the sun at around 7th mag. But smoothly brightened all the way into perihelion to about -13, becoming daylight. So now Lovejoy 2011 W3. Now this was the oddball. It started out very faint. It was 13th mag at discovery, went about 0.7 AU from the sun. This is the yellow curve here. So we gave it no hope of surviving, absolutely none at discovery. But something amazing happened. It just brightened and brightened and brightened and kept brightening. And it survived perihelion, but became headless afterwards. And this is an example of a failure, 2024 SWAN Atlas, where it broke up pre-perihelion. So it was found in September 2024, and it was by ATLAS, the ATLAS survey. So that's the red curve we're looking at now. So it was about mag 13 at discovery, but you can see here it wasn't brightening very much. It was flatliner, which is a really bad sign. And then it suddenly brightened, and then it suddenly faded. That's a no-no. That's destined to disintegrate, which it did. So when MAPS was discovered, it was very, very faint, about 17th mag. But we followed it very intensely, one of the most intensely observed comets in history, I'd say. So when you compare it to Lovejoy at 0.7 AU, it was running about 3 magnitudes brighter than Lovejoy. So the early indication was that it was larger than Lovejoy, and it could have been a medium-sized Kreutz with good survival prospects. But something happened around mid-March, where you can see it started to flatline. So that's a very bad sign. And then it brightened again, and then it started flatlining again. So, and we sort of lost it by the end of March, the end of March from Earth-based. So we had to wait for it to show up in the SOHO cameras. So this is a comparison. So here's the Comet Maps 26A1. about 2 days. So on the 2nd of April, about 2 days before it approached, before its solar hit approach. This was a Lovejoy, the survivor, in 2011. Out in the lower right here is 24 S1 Atlas, which failed, and an even earlier one, 2012 E2 SWAN, which was also a failure. So you can sort of say, oh yeah, okay, it's somewhere between the survivor and the failures. So D-Day was on the 4th of April 2026, where it passed 1.2 solar radii at around the 13 UT mark. So this is a LASCO C2 coronagraph comparison. So below here, you can see the very bright tail of the comet just before perihelion. This disk is the sun. So it was meant to go behind the sun, come out the other side, swing into the front of the sun, and then back down the other way. Now, unfortunately, this is it's cutting. It's not showing the. Can you drag it out of the way? No. Drag it out. How's that? Is that better? Yeah. No, that didn't work. That's okay. Trust me, you can probably just see the curvature here above there. So basically completely vaporized, failing to reappear at its expected location. So instead it produced an arc of dust, which was slowly dispersed by the solar wind. So there just wasn't enough nuclear mass to get it through perihelion. So the solar system basically lost another comet. But we're constantly learning about these comets. The risk is high, but the reward is great. So a bit of a disappointment, but not unexpected. But that's how comets go. They're made of ice and rock, bits of rock. So I'm sure the rockier parts are going to be the ones that make it through next time. But as a consolation prize, we did get another comet in May, a month later, CE 2025 R3 Pan-STARRS. So this was, I managed a couple of views of this using my C11 RASA and Canon 6D camera. So the shot at left was around the 5th of May, where it was about 4th magnitude. Had a very, very nice tail visually in binoculars, a few degrees long, from a dark skies, of course. And the shot on the right was on the 13th of May. So its perihelion was much further away from the sun, about 0.5 AUs, halfway between Earth and sun, which is why it survived. The closer you get to the sun, the dangerous it gets. So yeah, and it faded from say 4th mag to 6th mag by the middle of May. Hopefully some of you got to see that. I know it was pretty cloudy for a lot of the part. There was some very, very good photos with the comet and the Orion Nebula in the same field of view. So to conclude, the Kreutz family comets, I find, in my personal opinion, slightly biased opinion, they're the most fascinating objects in our solar system. They've been responsible for many great comets in history. And I've only gone through the main components. There are records of other Kreutz comets throughout history, which I haven't mentioned. So, for all you know, there could be something just around the corner. Now, there's still a lot to learn from the system and a lot to discover. Now the lifespan is going to be pretty short because the sun's going to consume the whole lot at some point in the future. Now, if you're a comet enthusiast, a comet hunter, Kreutz comets are strongly favoured for discovery in the southern hemisphere. And best of all, through Zdenek-Sekanina's studies of this system suggests that another cluster of bright Kreutz system comets may actually begin to arrive in the inner solar system over the next few decades. So watch the skies. Thank you very much.
Yeah, thank you, Michael. I think we have time for a few questions. Put the lights back on. A bit blinding. Okay, any questions out there?
Thanks, Michael. Really good talk. I'm just wondering, do you think it's possible that the -363, the first appearance, is actually part of a broken up larger comet again, and that's why there's all these different clusters?
You turned it off, I think.
Oh, yeah, sorry, yeah. Working now. That's correct. Very, very correct. So basically, the -371 is the breakup between lobe 1 and 2. But sure as hell, this comet's been around many times prior to that, before this major breakup. So that's why it's a little bit more complicated than what you've seen tonight. And it actually even makes it more exciting because there's potential members, and as I showed you with that histogram, it's not as straightforward as 1 and 2. There's bits of this and bits of that. So even with Lovejoy being POP3 and ending up headless, was that the main POP3 fragment? Is there another POP3? Is there another big one coming that's related to Terry's find? So that's the excitement of the whole system.
Ian, you had a question? Microphone's coming.
Hi, Michael. I noticed most of the images there just show the one tail. Is that you fairly unique for this class of comet that there's no ion tail?
100%. It's a very unique feature of the Kreutz Sungrazers. They are virtually silica dust. Like you hardly see any ion tail because everything's been destroyed because it gets that close to the sun. So the entire particle just gets converted to dust. And dust is very highly reflective. And one feature I didn't mention about the December arrivals of these comets is that the Earth is in a position of forward scatter. So you're actually seeing sunlight reflecting off the tail. So you get a super high surface brightness on the tail. So it's really, really obvious. Not like a faint Hyakutake with a very faint ion tail. These things are extraordinarily bright and stunningly bright, which makes them all great comets.
Hi, thank you, Michael.
Yeah.
I just got a question around the if just for me, for example, if I would like to start chasing the comet, what and where do I find the database to like classify this?
Chasing Kreutz in particular?
Anything.
Just comets in general?
Yes.
Yeah.
Apart from your website, obviously.
Oh, okay. Oh, geez. There's lots of websites, but I guess you want to know what's out there and when. Is that the main question? Become a member of ASSA and read the monthly Comet Bulletin. There's your answer. Become an ASSA member, get the bulletin and read my my monthly article on comets. I do have Facebook as well. I've got a Facebook, Southern Comets on Facebook. Yeah, southern.comets.info, or yeah, Southern Comets at Facebook. So I do post stuff there, but not as much as I do in the bulletins. Maybe so that's why it's good to be an ASSA member. So you get more information.
Any other questions out there? Oh, one more. Perhaps the last question, Peter.
Yes, thank you for that. Just in general, so comets are a material that will sublime and produce dust as they get hot. So an asteroid which is more iron, as that comes in, it won't exhibit any signature. But does the solar observer see them? They would give something off when they get close.
Asteroids?
Yeah, so because there would be asteroids going into the sun as well.
Well, funny enough, yeah, there is an asteroid 3200 Phaethon, which is responsible for the Geminid meteor shower.
So when they go around the sun, there's no
yeah, that's right. It's not showing any, doesn't show any tail.
Because it's still, a grazer would, sublime and melt and give off gaseous vapor, I would have thought, but I don't know the level.
Generally, asteroids are beyond Earth. You get very, very few that actually
come in.
Yeah,
Okay.
so that 3200 Phaethon has a very short small perihelion distance, and it looks like it probably is an extinct comet, which is why it actually shows you a meteor shower every December 14th every year. But yeah, mainly asteroids buzz around between Mars and Jupiter predominantly, so it's very rare that you get them. You do get transitional objects as well, so asteroids that show cometary activity briefly and then not. So
All right, cool, thank you.
Yep. But and also asteroids vary in density as well. So you get the ions, you get your stony ions, and then you get your stony. So there's a mix. You don't have a lot of iron ones out there. So yeah, actually the Psyche mission is going to be really interesting because that's apparently a totally iron object, which it's going to arrive there, I think, in a couple of years' time. It's proposed to be the nucleus of a planet that tried to form between Mars and Jupiter. So keep your eye on that mission, Psyche, PSYCHE.
Well, ladies and gentlemen, I have a presentation to make to Michael. Actually, two presentations. One is for those cloudy nights where it's not possible to view comets or analyse them too critically. It's an astronomical themed wine, as you might guess. But the other gift is for those critical nights, your water bottle that you didn't use. So, ladies and gentlemen, can we please thank Michael for a great presentation? I think I hit the wrong light switch when I was looking at question time. I'll try this present button. What does it do? Yeah, that's the button I meant to hit. Sorry, I blinded you all and woke you up with a start. But anyway, we'll move on. I have a few slides here. I have a few slides here myself, which I'd like you to see. Questions we've done. We have a YouTube channel where hopefully this video will join several others that we have in the past. So look for our YouTube channel, youtube.com/astronomy.SA. Prominent in there is a number of our past speakers, and also The Sky This Month by Paul Martinitis, who does a semi-regular update of what there is to see in the southern sky from a visual perspective. He does a great job summarising the things that come around again and again, and the new stuff and changes like planets and the like. So well worth tuning into our YouTube channel to see Paul's work. Couple of other announcements. We are still underway with our website and member database upgrade. Concerns our members more so than visitors, but our website is promising to be better and more responsive than it has been in the past. We hope to go live with that in early July. We've got a few things to do yet. We are fairly cemented with our existing system, and it takes a fair bit to unstick ourselves and put ourselves in a new domain. So please bear with us. ASSA Awards. Our awards, nominations and imaging awards are open. They opened on May the 1st, and they're open for another 30 days thereabouts, 27 days now, closing June 30th. So please get your nominations in and your images for the awards. I think we have a few dozen entries in our imaging awards already, and they often cause issues for our volunteer administrators because they come in at last death knock. So please try and avoid that. Give us all a break and get them in earlier instead. One of our previous winners there, somebody had the thrill of seeing auroras in the far north. Jane Brooks was one of our winners last year in the smartphone category. Pretty remarkable results from a smartphone to capture an aurora. So consider your smartphone images. The awards night itself is on Friday. That's an important distinction. First time on a Friday because it's a much more economical arrangement with our hosts, which means savings for you as members. So please consider coming along on Friday, the 4th of September. It's the premier night for ASSA, the awards, and it's a great, fun, social night for everyone. More details will be in the bulletin and via our usual communications channels as we get closer to that date. Activities for June, ASSA at Home, 12th of June. Member viewing nights, Stockport, Saturday the 6th and 13th of June. 6th of June coming up this Saturday and the one after that. Tuparang, the 20th of June. Meldanda also on the 3rd of June, but since we have no coordinator, it's a fully BYO everything. Power, thermos, tent, if you stay the night, until a coordinator is found. The coordinator wouldn't help you with accommodation, of course. That's still your own problem. But Meldanda is an amazingly dark site and well worth visiting if you haven't done so already. Astro Imaging, our largest special interest group, meets on the 30th of June, 7:30 p.m. with Richard Mulak. And thank you, Colin, for putting in a plug there for our imaging group. If anyone's interested in imaging, well worth joining. And our primary means of communicating with members is through ASSA's special interest group Facebook page. So there are new images coming through that Facebook page every 2 or 3 days and a lot of discussion that occurs between members. It's a very lively place to catch up with imaging. Unfortunately for the public, we just missed out on a public star party this month because it was completely clouded and rained out. But the next opportunity is 15th of August. As we get closer to that date, more information will appear in our media, being Facebook page and website. Public viewing nights at Hawthorn Dean Oval will resume again in October. Similarly, we'll let people know as we get closer to that date. Next month, education session, Colin Hill will be back to tell us all about great discoveries in astronomy. Thank you, Colin. And we have a free public lecture with Dr. Tona Stevenson from New South Wales, who'll be telling us all about South Australia's participation in the great 1922 eclipse, which helped prove general relativity. So I'll look back into the past, topical theme for eclipses coming up in 2028 and 2030. Now, ASSA is a participant in Science Alive at the Adelaide Showgrounds, August 7th to the 9th. If you're an ASSA member and you have a Working with Children clearance, please consider volunteering for this great fun activity. It's at least 2 days, possibly 3, of intensive activity with youngsters, certainly on the first day when it's the schools visiting, but after that it's the public with parents and kids really enthusiastic about science generally, and it's a great opportunity to tell people about the wonders of the night sky and astronomy generally. So please contact Michael Chartres, who's in this meeting. I think I saw you, Michael. Can you put up your hand? Yes, Michael is holding his hand up. If you're interested in volunteering, I certainly encourage you to volunteer. See Michael Chartres after the meeting. We have information sheets and merchandise at the back. Have a look as you go out to the foyer for supper afterwards. I need to talk about our sponsor, Adelaide Optical, in Gawler Place. Yeah, if you're considering an astronomical purchase of some kind, and we all consider, but not often spend, of course, but if we spend money with our sponsor, that also helps ASSA. So please consider and talk to the people at Adelaide Optical for your next astronomical purchase. The benefits of membership. There are various green dots on the page there, which are exclusive to members, and various yellow dots there which indicate that you can still enjoy some aspects of ASSA as a public visitor without being a member. However, the benefits of membership are extensive, including particularly member nights. That's the social side and the viewing side of ASSA. Some shots of our facility at Stockport at night, all lit by red lights to protect night vision, and people doing their various activities, including visual and imaging astronomy. One of the highlights, some of the highlights of the year for me anyway, are getting away to the Alpana dark sky camps, particularly if you're like me and you live in near inner suburbia. You appreciate the dark sky whenever you can get out there, and Alpana is one of our sites. You can see telescopes set up there on the right-hand side top picture, and the campground facilities in the bottom left during sunset. Similarly with Bendelby, a bunch of astro imaging enthusiasts there looking happy with the performance of their equipment, and the campground below with other telescopes spread out. Both are great fun to attend, great social occasions, particularly for the Bendelby trip. It's a great place for people who have joined the Facebook group to meet socially face-to-face, because usually they meet by Zoom and twice a year at Bendelby or at the dark sky camp there. So subscribe and follow us on social media. Our general ASSA Facebook site is facebook.com/astronomy.SA, similar with YouTube. And for those of you on Instagram and X, I think those links still follow through. Thanks to our helpers tonight, Brian, who does the supper, and my compatriots who attempted to get recordings underway earlier and delayed things somewhat through their learning processes. We need volunteers all the time, and yeah, please see me if you are interested in volunteering for some of the many roles we have in ASSA that remain unfulfilled. Thank you for joining us this evening. Tea and coffee is available in the foyer. At this stage, I'll close the meeting and I'll stop the recording. Thank you all for coming. Hope to see most of you again next month. Tell your friends. Bye for now.